have already discussed the topic Faraday's law of electromagnetic induction and the basic equations which helps to derive the Maxwell's equations of electrodynamics and induced electric field. Today I am going to discuss the topic self-induction and mutual induction. Do you know what is self-induction? Inductance is the tendency of an electric conductor to oppose the change in electric flow through that. When an electric field flows through a conductor, it creates a magnetic field around that conductor. We all know these definitions. Do you remember these definitions? Okay, now we can go through the physical equation of self-induction. As we know, when we consider a closed stationary loop, the current I is passing through that coil. Then the magnetic flux in that loop can be explained as phi is equal to surface integral B dot ds. And also we know, according to Biot-Savart law, the magnetic field created there can be represented using mu 0 I by 4 pi integral dl cross r by r square d2. From these two equations, we can say, from these equations, we can say phi is proportional to B. From this equation, we can say B is proportional to I. When we consider these two relations, we can create phi is proportional to I also. Phi is proportional to current flowing through that loop also. From this, we can write phi is equal to L into I, where L is the self-inductance of the coil, which is the proportionality constant. The next topic is mutual induction. What is mutual induction? The mutual induction is the phenomenon of inducing an EMF in the secondary coil due to the change in current in the primary coil, and hence produces a change in magnetic flux in the secondary coil. The next topic is mutual induction and Newman's formula. Consider two closed loop C1 and C2 and the stationary currents I1 and I2 are passing through the concerned loops, and DL1 and DL2 represent the line elements and DS1 and DS2 represent the surface elements of these two loops. We know when the current passing through the loop C1, a magnetic field is produced in that loop. That can be represented as B1. B1 is equal to mu 0 I1 by 4 pi line integral dl cross r by r square. Due to this magnetic field B1, there produces a magnetic flux in the coil C2. That can be represented as phi 2 due to 1 is equal to surface integral S2 B1 dot ds2. Phi 2, the magnetic flux produced in the second coil due to the magnetic field in the first coil is equal to surface integral S2 B1 dot ds2. And also we know phi 2 1 is proportional to I1. From this we can write, when phi 2 1 is proportional to B1, we can say phi 2 1 is also proportional to I1. So I am going to write it as phi 2 1 is equal to M21 I1, where M21 is the mutual inductance produced in the second coil due to the current flowing in the first coil. That is phi 21 is equal to M21 I1. In same way, I can write the expression for the flux in the second coil as first coil as phi 1 due to the current flowing in second coil is equal to M12 I2, since it is created due to the presence of current flow in the second coil. Hope you understand. That is phi 2 1 is equal to M21 I1. Phi 1 2 is equal to M12 I2. Then we got equal to M21 I1. Phi12 is equal to M12 I2. Phi21 is equal to integral S2 V1 dot ds2. Then substitute B is equal to del cross A in equation number 3. Then equation 3 will be phi21 is equal to surface integral del cross A1 dot ds2. Okay. Then applying Stokes theorem to the RHS of this equation implies closed integral C2 A1 dot dl2. Okay. Then the vector potential due to the current I1 in the loop C1 will be A1 is equal to mu 0 by 4 pi closed integral C1 I1 dl by R, and it has equation 5. Now substitute equation 5 in 4, that is substitute A1 in this equation. Then we get phi21 is equal to mu 0 I1 by 4 pi closed integral C2 closed integral C1 dl1 dot dl2 by R. By comparing this equation number 6 and equation number 1, we can write the expression for mutual inductance M21 and M12. We got the expression for mutual inductance M21 is equal to mu 0 by 4 pi integral C2 integral C1 dl1 dot dl2 by R, which is the Newman's formula for mutual inductance. Then also the mutual inductance depends on the size, shape and the relative position of the loops we consider. When the loops C1 and C2 are interchanged, there will be no changes in these equations. So we can say M21 will be equal to M12 will be equal to M. That is, the mutual inductance is same for the both cases. Then when the current passing through the two loops are considered as same, I1 is equal to I2 is equal to I. We know phi21 is equal to M21 I1, phi12 is equal to M12 I2. Already we know M21 and M12 are same. Then we can say when the current passing through are same, phi12 will be equal to phi21, that is the flux in that both loops will be same.